Okay, today's video is going to cover perimeter with polynomials. We're going to find the perimeter of figures that have unknowns, which we know as variables in algebra. One key term today, it's what perimeter means. Perimeter is the distance around any shape. So if you took the side lengths of a rectangle or a triangle and you added them all up, you would get the perimeter. So the formula that we're going to use, because it's the easiest formula to calculate for perimeter, will be perimeter equals, and I guess this is for the rectangle because we're going to be primarily dealing with rectangles with perimeter. So perimeter for rectangle equals 2 times the length plus the width. So if you think about this rectangle right here, we know that this side and this side are equal lengths, and we know that this side and this side are equal lengths. So if we add up the length and the width and then we double it, that will give us the perimeter for all 4 sides. Okay, let's go ahead and use this in a couple examples today. So here's example number 1, and the problem tells us a rectangle has a length of 8v squared minus 7 plus 6v to the third, and a width of 7v to the third plus 7 plus 2v squared. So you can see here that the length and the width are polynomials, and what we're going to do is we're going to use our skill of adding polynomials to figure out the perimeter of this rectangle. So let's go ahead and identify what the length and the width are. So we can say that the length here is this, obviously this top one, and the width is this polynomial right here. The second step will be to configure each of these in standard form. So our width in standard form is, our length in standard form is 8. Nope, it's not 8. It's 6v to the third, that is the highest variable, plus 8v squared, plus or minus 7. I'll put the plus right here. And then our width for this example is 7v to the third. The next highest variable is squared, so 2v squared plus 7. This represents our width. And so now what we're going to do is we're going to add up the like terms, and it's nice that both the length and the width have the same exact variables to the same exact power. So their like terms are already lined up for us, so we just have to add them together. So we can say, okay, when we add our third powers together, the coefficients add up to 13, v to the third. Our coefficients for v squared add up to 10, v squared. And our coefficients for our constant add up to 0. And I don't need to write plus 0, but if I wanted to, I guess I could write plus 0. But this isn't going to affect the answer. So now the fourth step after we add up our like terms is to double the sum. So this is the sum right here, and all we have to do is double the sum for the perimeter. So we'll go ahead and multiply this thing by 2. That's what doubling means. So we're just going to distribute this 2, or we're just going to double 13. When you double 13, you get 26, v to the third. Notice how the exponent's not changing. We're not multiplying bases, so the exponent's not going to change. We're just multiplying the coefficients here. And then when we double 10, we get 20, v squared. And here is the answer that you will put in for the perimeter of this rectangle. Example number 2. So we have our length and we have our width. We can go ahead and say that the length is this because it tells us, and obviously the width is this because it tells us. So our second step will be to put the length in standard form from highest to lowest exponent. Highest exponent in this particular problem is p squared. Then we've got a 6p, and then we've got a constant. Here we've got a p squared, so we can write that right under p squared. Then we've got a p, and we have a constant here. And I don't know why I'm not putting the plus right here between these two. Okay, now that we've done that, the next step will be to add up like terms, and you can see that these are like terms. We got squareds, we got first powers and we've got constants, so we can go ahead and just add straight down. Our coefficients add up to 8. These coefficients add up to a -4. And these coefficients add up to a -1. So this is adding the length and the width. Now we've got to double them for the perimeter, so let's go ahead and double that now. Essentially we're just multiplying by 2. Double 8, you get 16 p squared. Double -4, you get -8 p. Double -1, and you get a -2. And this is the perimeter of our rectangle, and this is the answer that will be put into Schoology. Example number 3. Now this is a good example, and you'll see why in a second, but our first step here is to identify the two. So we've got our width and our length. And now we're going to order the length in standard form. So the highest exponent here, we've got a 4, we've got a 2 power, and we've got a constant. And if we do the same thing for the width, we've got a second power, we've got a first power, and we got a third power. So you can already see that there's some terms that we won't be able to add up together because they don't share all like terms. So our 4 for the length will go first. So we've got -6p to the 4th. Then we've got our next highest power, and I'm going to skip a blank. So like we've got things that are to the 4th power, things that are to the 3rd power, things that are to the 2nd power, things that are to the 1st power, and things that are constants. So this length has nothing to the 3rd power, but it's got something to the 2nd power, so I'm going to go ahead and write it right here, 4p squared. And then it doesn't have anything to the 1st power, but it's got a constant of 6, right? Now for the width, the highest power here is a -5p to the 3rd, so I can go ahead and write that right here. Then the next highest power is 9p squared, so we can go ahead and write plus 9p squared. And then the lowest power in this one is -6p, so -6p. So you can see here that we don't have fourth terms to add up, so when we add these together, really all we are going to do is add this to 0, and -6p to the 4th plus 0 is just -6p to the 4th. Same thing here, we've just got -5p to the 3rd. Here we actually have some coefficients that we can add together. 4 plus 9 is a 13p squared. Here we have nothing again, so we can just bring that down. And then same thing with our constant. So sometimes you're going to have problems where you don't have like terms to combine for certain powers. Now we're going to double our answer. So we get -12 p to the 4th, -10 p to the 3rd, plus 26 p squared minus 12p plus 12. Lot longer answer. This polynomial has 5 terms. 1, 2, 3, 4, and 5. Okay, example number 4. Rolling through these. So again, you can see that there's some terms that we're not going to be able to combine. So all I'm going to do is I'm going to go ahead and write above him the powers, so I know, okay, we got a 3rd power, 2nd power, and a 1st power. And then for this example, we've got a 2nd power, so they have a 2nd power in common. This is a constant, and this is a 3rd power. So they have 3rd powers and 2nd powers in common, and we're going to be able to combine. Now I can go ahead and rank them from highest to lowest exponents. 8x to the 3rd minus 8x squared minus 9x. And then for the width, we have x squared. We've got a plus 3x to the 3rd. And we've got a constant, so we can say plus 3. So here we can just say, if we wanted to write something here, we could say plus 0x, because it doesn't have a first power term. We can just put a 0 in front of it. If that's what you want to do, you can. Now we can go ahead and add them together. So our coefficients add up to 11 here. Now here, this x squared does not have a number in front of it, so if you want to put a number, just so you know that there's 1x squared here, you may. -8 plus 1x squared is a -7x squared. minus 9x plus 3. Now we can go ahead for our final step and double our answer for the perimeter. So we've got 22x to the third minus 14x squared minus 18x plus 6. And you're asking me, why am I doing this so fast? Well, if I multiply something by 2, all I am really doing is just doubling the number and making sure to keep the sign of that number. Okay, for our last example, this will be example number 5. And I'm going to do the same exact thing. I'm going to go ahead and identify the powers for each of them first. So we've got a third power. Oops. We've got a first power and a second power. And then here we have is a first power constant and a second power. So you can see that they share a first power and a second power. Now I can go ahead and rank them. So for the length, we've got 7x to the third plus 2x squared minus 5x. And it doesn't have a constant term, so I can say, okay, plus 0. If I wanted to write the 0, I could. This one doesn't have a third power, so we're going to start here with 8x squared. Then we've got a minus x. Then we've got a plus 5. Now I can go ahead and add these together. So we can just bring this down, 7x to the third plus 10x squared. Now we've got a, if we wanted to write a 1 in front of this, we can. Oops, that's a terrible 1. But you know it's a 1. Hopefully you do. Probably don't. There we go. We've got negative 5 minus 1 is a negative 6x. And 0 plus 5 is obviously 5. Now for our final step, let's go ahead and double it. And we get 14x to the third plus 20x squared minus 12x. Why did I write 16? Plus 10. And this would be our final answer. So today, hopefully not too difficult, just making sure that you're adding up your like terms for the length and the width, and then once you've added up your like terms, making sure that you double it before you go ahead and type in your answer for the perimeter. Good luck.